So dear student, it's time to demonstrate the things which we have already covered in previous video. Okay, so this is a differential equation and we are going to solve it with the method which we have studied in previous video. So in previous videos, we have already covered what is first order linear differential equation, how to solve it, as well as we have covered reducible to first order linear differential equation. Okay, so I will mention both the differential equations here. The first order linear differential equation having this standard format, P y is equal to q, where p and q are functions of x, and reducible type 1 is dx by dy plus p dash x is equal to q dash. Okay, so if we can convert the given differential equation in first format, I will go the method, corresponding method, getting, and if we can convert the given differential equation in the second format, then I will go for the second method. So now the question is what to do, how to convert the given differential equation in first or second format. So here I am going to convert in second format. Okay, since in last video we have already covered. So maybe some questions in your mind, maybe you will think, but at the time of examination, how can we realize which method we have to follow, which format we have to bring? So I will tell you the solution. Getting? So if such unknown problems we have, I will try for the both methods, and which will be suitable for us, I will go with it. If you want dy by dx, then you're supposed to shift dx on that side. Agree? Dy by dx if you want. Dx will be shifted there and you will have dy by dx. But it must be a single term. So that's why this bracket will be shifted here in denominator. Right? All of you are getting the point or need to write? Okay, I will mention. So if you shift dx there and this bracket here, you will have 1 plus y square upon e raised to tan inverse y minus x. And here you will have nothing, and on that side you will have dy by dx. But see, a very huge term we have got in denominator, and there is a minus sign. That is a critical thing for us. If you have a minus sign, you cannot make them separate. So you cannot generate three terms directly, easily. Getting? So I will not go for this format. Okay, so I will not bring dy by dx. I will go for dx by bi. I hope you have understood. Okay, so when in exam also, when you have such problems, you need to think, okay, we need to go for which format and which will be more comfortable for us. Actually, the given differential equation can be solved using various methods. There is not a single unique method. Getting? You will have multiple methods also. In that way you can solve. So yeah, first method is not suitable for us, so I'm going for the second method. In second method, what we want dx by dy, dx by dy. It means we need to shift dy on this side and we need to shift that bracket on that side. So let me write, I will directly write, we have dx by dy, right? This is equal to e raised to tan inverse y minus x upon 1 plus y square. So you may think the same critical conditions created here. Since we have 1 plus y square, getting, and plus sign is there, so you cannot make them separate. Here also we want three terms, 1, 2, 3. But this time at least I can divide separately. A very small term we have, so I will divide separately. E raised to tan inverse y upon denominator minus x upon denominator. Let us do. Okay. Yes, so finally we got three terms, but we have two terms in left hand side and only one term in right hand side. It means, and here we have a two terms in right hand side. That means out of these two terms, we need to shift one term on this side. So now the question is which term should be shifted. Okay, so you can easily see we have x here. The term with x should be shifted on in left hand side. So here we have a term with x. So let us shift it here. We have a minus sign here. If you shift it here, you will have the plus sign. Dx by dy plus x upon 1 plus y square, and there you have e raised to tan inverse y upon 1 plus y square. So finally we got this format. Okay, let us check again. Dx by dy, single term we got. X into something, function of y, p and q, p dash and q dash are functions of y. We got it. And here we have the function of y only, and here we have a function of y. So it is clear. Okay, so the given differential equation in that format. So let me mention what is p dash and q dash. P dash is nothing but multiple of x. The multiple of x is nothing but we have something in denominator. So 1 upon 1 plus y square is our P dash. Q dash is entire left, right hand side. Okay, so we got P dash and Q dash. Yeah, so let us move further. So in a single, in two steps, we directly get the answer. The first step is to find integrating factor, and second step is last step, which will be the solution. So integrating factor, let us find. The formula of integrating factor is e raised to integration P dash dy. We integrate with respect to y here. Let us find e raised to integration. What is my P dash? 1 upon 1 plus y square dy. So this is our P dash. Okay. So now the question is how to find the integration. So to get the solution, okay, to find the value of this integration, you must know this formula. Do you know this formula? 1 upon s square plus x square. 1 by a tan inverse x by. Okay. So actually when we solve this first order linear differential equation, we need few selected formulas of integration. I never ask to prepare all formulas of integration. Getting? I asked to prepare just selected formula and frequently we use them. Okay, frequently we use them. So it is one of it. Several times we use this single formula. Here also I'm going to say. Okay. So if you compare at a place of x, we have a y here since we have a function of y. A square is nothing but 1. That means value of a is 1. So let us put x, replace x by y and a by 1. So the integration will be e raised to 1 upon 1. See, a is 1. So 1 upon 1 is 1. No need to write. And tan inverse x we replace by y. A is 1. So tan inverse y by 1. That means e raised to tan inverse y. So finally we got integrating factor. Okay. So now just last step is remaining, which is a solution. So let us do that thing and then we will stop. Okay. So let me mention solution is, so I will write the format first, e raised to integration, x e raised to integration p dash dy is equal to integration e raised to integration p dash dy q dash dy plus c. Okay. So simply we will put the values and we get the answer. Okay, let me remove this part, it is not required. Let us put the values. What is e raised to integration p dash dy? Yes, it is e raised to tan inverse y. Same e raised to tan inverse y into q dash this one. Okay, let me put it there. E raised to tan inverse y upon 1 plus y square dy plus c. So this is equal to integration. So let us simplify. Okay. So looking complicated, but actually it is very easy. You can easily see these two terms are same. Base is same. Multiplication is there. You can add powers. Right? Tan inverse y plus tan inverse y. 2 tan inverse y into this. Let me write separately. 1 upon 1 plus y square dy plus c. So now inside the integration we have two functions and we have to solve the value of this integration, right? So when we have multiplication of two functions, generally we go for integration by parts. Integration by parts, that means u into v formula. But see, it is not that much easy since we have exponential function with some critical power tan inverse y, and the second function is also quite difficult, 1 upon 1 plus y square. The second option we have, that is substitution. Just put something. Okay. So now the question is what to put. Okay, what we have to put here. So generally if you remember the formulas of derivatives, you will get an idea what to put. Whose derivative is present over here, that thing you need to put. It means if I put tan inverse y is equal to t. What is derivative of tan inverse y? The derivative of tan inverse y is 1 upon 1 plus y square, which is present over here. That means definitely I need to put for tan inverse y is equal to t. The problem itself gives you hint how to solve, getting what should be the substitution. Generally, when you have such kind of integrations, okay, where you have to go for the substitution, derivative is always present there. Okay, most of the times with some adjustment also sometimes, but derivative is always present here. You must know the formula. You must able to recall the formulas of derivative. Then you can easily get an idea what to put. Okay. So yes, let me remove this part. I'm going to do the same. I'm going to put tan inverse y is equal to t. Putting tan inverse y is equal to t. So when you put anything, the second step is to take its derivative. So let us take derivative. Derivative of tan inverse y is 1 upon 1 plus y square. I should write dy here. Derivative of t is 1, so I write dt. Okay. So I must mention here, okay, I must mention whatever I am putting in the right hand side only, not in left hand side. See, left hand side is already solved, no, nothing to do with it. So we have to solve this integration which is in the right hand side. So whatever I do the substitution, it should be for right hand side. Let us solve. So x e raised to tan inverse y, agree, integration e raised to 2. Tan inverse y is t we are putting, so t 1 upon 1 plus y square dy. The entire term will be replaced by dt only. You can easily see here. So both these terms should be replaced by a single term dt. So dt plus c. So what will be its integration? You know that integration of exponential function remains same. So here also integration of e raised to 2t is e raised to 2t, just whatever the multiple of t we should write in denominator plus c. That's it. So maybe you will think problem is over. The problem is over, just last step is remaining. So variable t, we have brought that variable t, getting, so that was not a given variable. So its original value we need to resubstitute, which is tan inverse y. So e raised to 2 tan inverse y by 2 plus c. Okay, so let me just copy left hand side. So this is required completed solution. Okay, so this is the required solution. So in this way we got the answer. I'm sure you understood. So if you are really understood, you can try for the next practice problem. Okay, and if you have any difficulty, it will be covered in my next video. Just make a screenshot of it, then be ready for the practice problem. So this is a practice problem for you. I agree it is looking heavy, but at least you can try. If you try, I'm sure you can definitely solve. And otherwise, you can, if you want the answer, you can watch my next video. In next video, I'm going to cover it. Thank you. See you in next video.